Okay, I'm recording right now, and everyone see my screen all right. So before we start the next session, I just want to briefly tell you guys some changes in here. So the first change is, oh, sorry, someone messaging me, I think. Okay, great. You guys can see it. So awesome. So because today earlier, I was going through some of the documents with Suli, and I see that there's some area that I didn't mention. So I want to use this session to briefly go over some of the areas. So the first one would be the schema design. So before I didn't mention on much. So but in here I input like schema design, fact table, dimension table, schema, what is schema on read and what is schema on write. Like I mentioned with Silly in earlier, my point for this post is just providing you with some of the keywords so that you can Google later on, because talking about knowledge about database and data in general is very large. So I prefer to provide keywords that is related to DP 200 and DP 300, which is the database administrator, so that you guys can start study for these contents from now. And yes, another concept that I want to mention about schema and database is Kimball. Let me remember what is the formal name on that. Kimball style relational. So this is also a very important concept in the data architecture. So it's a Kimball versus Imnon. So this is very these are the model that very important in the relational dimensional modeling or schema design. So please go over it in your time when you are at home. So this is one change. Oh, I see someone messaging me. Let me see. Oh, that's, hang on. Oh, hello, Brian. Great that you joined. So I'm just go over some of the concepts that I'm missing, because today when I was talking with my friend Silly, there's some uh, there's some content that I feel that I didn't include. So I go over and include some more content for today, and I'll try to finish all of the important main key content, and then for sure next week we should start working on Azure, because I don't want to delay this later. So anything that missing now, we will mention it again in the Azure sessions, because we have 3 sessions on the data engineer so far. So let's start in here. Sorry, I'm a little bit slow because I use two computers to go back and forth. So, okay. So let's go to this slide. So, Harris and Sully, I believe you guys already have knowledge about my Spark session. Brian, do you know about Spark yet? I believe you do, right? Okay, that's good. And we all know about Spark, so I'll go briefly on the Spark session. I won't go as deep as I were in the normally sessions that I had with in the Azure or like the Udacity class, because everyone here is know about Spark already. So I'll mention it again when we go through like the big data session on Azure. But for now, I'll go it just briefly, so we don't waste everyone time, because I know like it's late for like Brian, for me, for Sully already. So before we go further, let's just recapture of what we talk. So we talk about data warehouse, we talk about data lake, and we also talk about OLAP and OLTP. So I want to highlight that not understanding about OLAP, OLTP, and row and column that is very, very important. And you need to remember these difference by heart, because it's not only come up in when you work with database, but also like multiple exams in different cloud later on. Because remember what I say is that DP200 and DP300, the knowledge is very transferable regardless of which system you work with. So these are the fundamental that you need to remember. Okay, so the same thing with distributed system. It will be almost similar architecture in regardless of cloud that you use. So study this one by heart, and this is the reason why I separate this section from the Azure training content. So we'll go through the distributed system and the synchronization and the pitfall. And we also talk about ACID and base, which is the core for relational and non-relational model. So we talk about CAF theorem, and today when I was discussing with Silly and was showing her some of the documents on Azure, then I realized that there's something that I'm missing because because there's a very influenced paper. Let me show you. Sorry for jump. From 2010, from Daniel Abadi, talk about the shortcoming of CAP theorem and how he create kind of like an extend theorem from CAP theorem, which is I believe the pronunciation is PACELC theorem, which is now a lot of database use, which is MongoDB, CosmoDB. They all use this theorem, and this theorem again is an extension of CAP theorem. So that's why I want to include it here so that you have an easier time to transit into this database and to understand about the fundamental core, because this will help you to be a better solution architecture. So before I jump to this, I want to revision a concept of partitioning, and I believe this raised some some confused, because partitioning in the database we have the partitioning, and in network we have the partitioning. So this partitioning is not the same. It's a very different concept, and I don't want you guys to mix up, so I want to include it in this section. So remember in here, I talk about partition tolerance, right? And I hope you guys still remember what partition tolerance is. So you guys remember this? Just want to quiz you guys a little bit. So, okay. So partition tolerance, partition is when the network take a break. Basically that's what partition mean. So partition here is mean there's a communication break, and we will see that more in how partition will carry another meaning in data in the later session. So basically I want to mention that network partition is when one or more server or node can talk to one another. So it can arise in things like issue with network infrastructure. So like your port is misconfigured, or your adapter break, or any issues. For like in Vietnam we often have issues like shark eat the cable, right? So situation like this, network partition will arise. And remember this because next slide we will have another partition which is related to data, and it's a good kind of partition. So we go over consistency already, so I won't mention. So I want to mention on this uh, PACELC theorem, and I want to include the original paper in here because it's very great if you guys can spend time and have a look on this, because if you want to interview for higher position, then it will be very impressive that you guys can mention and can talk about different theories on this. Okay, so let me summarize for you guys on this concept. Sorry, just a moment. Okay. Right. So the so PACELC, like I mentioned, is a default version of DynamoDB, Cassandra CosmoDB. So they use PAEL system. So let me pull up a picture for you. Let me see what I use. Yeah, because I'm in a different computer, so I didn't. Oh, so let me just. I think. Okay, so let me have this for my homework. Is that I'll pull up a chart. Let me see if I can see this from my computer real quick. Just give me a moment. I should have include the chat of PACELC. So basically, it's a matrix to say which one that you prioritize over. And okay, so I guess I don't have that right now. So let me try my best to talk about PACELC without this magic. That's weird because I was having this. Okay, so let me try to explain it without this matrix, and I'll supply you guys with the matrix later on. So as you understand in the last slide, I talked about partition, right? So partition here means when network take a break. So when it exists, then what are you prioritize? So the default version of there will be two cases. So if it exists, then this, for example, in Cosmo DB, is a PA and EL. That means when partition exists, then the Cosmo DB will prioritize availability. Else, that means when partition not exist, then it will prioritize latency. So that means when you read the matrix that mentioned about PACELC theorem, and you see like, and when you see the people say like this model is PAEL, let me write it out for you guys. Oh, actually, you guys can take a look here. Okay, I have the footnote here. So you see this, you will see this over and over again. So that's why I want to put it here. So when you read this, then you need to remember about this chat. And I go over about availability, consistency, latency already in the last section in the CAP theorem, so I won't repeat it, but I want you guys to notice of how to read in like how the system design, because they will just say like PAEL, and you need to go back to this theorem because you see like DynamoDB, Cascada, CosmoDB, like all of the modern distributed system, they all use this theorem. Today, they all use this theorem, so you need to understand what this theorem is, the start of it, and how to read the system. So when there is a network partition, then they will prioritize the availability, and when it's not, then they will prioritize latency. So that means they give up consistency for availability. So it's more important for them to have the system available rather than have the most updated data. So that what it means when you read the letter. So you guys have questions so far on this? So of course, in contrast for the else, so EL, that means like under the normal operation, they give up consistency for low latency. So they rather have the low latency than they have the consistency. Okay, I promise I'll supply you guys with a matrix in the next session. I don't know why I didn't include this, but please go over this and read about what is the what is each of the system support in here, because it's very important to understand this first before we can start with Azure on this. And you understand each letter already, you understand why we cannot have all. So that is the main the core concept, and from there you can understand why people design the system in that way and what the trade-off of each system. Okay, so let's go to, let me go down to this. So we go over Hadoop, HDFS, HBase already, and we know what distributed system is. So let's talk about other concepts in the distribution system data. So okay, so I want to mention with you this concept about hash table, distributed table, you know, like what hash is. And in here you can see about table partition and also a sharding. So a partition here, it doesn't mean that there is break in network, but it's just a way to divide data. And sharding is the horizontal way of partition. And we'll go over this each by each so that we can understand this. And we have some more concepts and like data skew and some pitfall of sharding. And after that, we have like about 10 minutes to go over this. And then I will talk about a little bit about NoSQL and also like some security features. So let's go back here and talk about this. So hash table. So table can map key to values. So you know, so you remember back in your class you have data structure, right? And you remember hash function, hash as a data type, right? Where, let me pull up on this for you. Okay. So you see here, so in the hash table or hash function, so let me grab hash table too. So basically, hash table is that where you can map key to values. So there's key and their value, and you map them to one another. So and that is a hash table. So to extend this, we have the distributed hash table. So this here, so basically it just means that it's a distributed system that provides a lookup service similar to hash table. So when you talk about hash, there always a key and value pairs, and it even similar like that in hash algorithm too. Like when you see about hash, there always the concept of key and value and pairs it together. So let's talk about distributed system. So distributed table. So now you understand that distributed system is that a multiple servers that act like one and can compute and use the strength of a cluster to solve the issues while appear to be like one server, right? So it's similar concept to distributed table. That means it appears as single table, but then actually the rows are stored across distributions. So the 60 here is actually the Azure way. Normally you don't have the set number of 60. So another concept I want to raise to you is a table partition. So table partition enables you to divide data into smaller groups of data. So in most cases, tables are created in date column, and remember this. So so sharding will be very different from this, and you don't want to use date column for sharding, and I'll explain to you why on this later when we talk on the sharding concept. But remember this, when you want to do partition on table, you want to create it in date column, but then when you shard, you don't want that. And partition can benefit data maintenance and query performance. However, too many partition can hurt performance under some circumstance. Okay, so let's talk about sharding. So I actually have a blog on sharding. Now let me go on this. Is am I going with the alright space, or do you want to go slower or review some more concepts? Let me know. Okay, I think I'm here. Okay, so please ignore this. So we have partition. We have horizontal partition and vertical partition, right? So sharding is called horizontal partition. So it split data in smaller subnet and distributed. Oops, sorry, and distributed across database server, and each server is referred to a database shard, and you can read more on the advantage and disadvantage in here. So that is your homework. But I want to go here to the best practice for sharding, because why? This is a part of the Azure DP 200. It will ask you on the different data solutions and how to optimize it. So sharding will be one of the key area to optimize data, and it's also a very transferable skill. So recently, one of my friend is actually interviewed for Facebook, and one of the key area that he will ask on is on scaling and optimizing database. So if you just have one server, one database, it's easy, but how do you scale to millions, to scale to support like millions of users? So that where is scaling and optimizing database and sharding and distributed system go into place. And that's why I also believe that in DP 200 there will be a lot of questions regarding to scaling and regarding to distributed system and the tools around that more than relational database, because big data and is really a strength of cloud. So you feel free to read this ahead. I already produced few articles about different DP 200 topic, and we will go over it in the class, but you feel free to read it before this. So here advantage of disadvantage, but I want to go to the best practice in here. So we normally should have mentioned these four best practice. So remember, like I say, create table. Oh, I think it was in partition. Okay, okay, sorry. I was I don't know why the partition option partition. Okay, so this actually belong to the partition. So my I don't know, I have a little bit light head today, so my partition section actually didn't got saved. Instead it's saved into sharding, so I'll edit this. But go back in here, we can still carry this concept in here. Remember I talked about table partition, right? So this partition best practice for creating partition, but then the sharding in here. So when you shard, remember to group the database in the same shard and avoid relational dependencies. And transaction should only cover on a single set. And I'll also have the Azure best practice in here for you guys to follow. So you guys go here. Oh, okay. So here. So I'll pull from the sharding best practice from here instead, because I think I messed up a little bit with my article on there. So you can see here in here they also have the advantage and disadvantage, and you can see like different database there is implementation of sharding and how they control sharding. For example, HBase, they provide automatically sharding, and controlling and managing sharding is very important. And each database, they will have different tool on that. So let me see some disadvantage. Yes, so you need to aware of the disadvantage in order to optimize it. I'll get it from Azure. But remember on this, and it's you can see a lot of this is very similar to partitioning disadvantage. For example, increase the complexity of SQL, and single point value and value server of more complex. So all of this, please remember by heart, because this will be asked over and over again in our test. Okay, so let's go back on this one and talk about this column. Sorry. So let's talk about column index, column store index. So remember, we talk about columnar data format, right? So a column store index, just a technology to store and retrieve and managing data by using columnar format. So that's all. But then why I want to put everything here, because when I go over in Azure documentation, and also like in other cloud documentation as well, these are the jargon. So jargon is like the industry vocabulary, it's the over and over again. It's appear a lot, and I want to put it in here so you guys have the same vocabulary with me. So when you go to documentation like this, we will have the same understanding. In like partition, we will have the same understanding, like cluster column star, what is column star, things like that. And I think it's very useful for us to have agree on the same jargon before we go any further on this. Because for data engineer especially, we will have to rely a lot on Azure materials, and we have to go to here to like really nail it. And it's the best way to learn. It's not through these slides. These slides will be just providing you keywords, but we really need to nail in here. Okay, so let me see if there is something else we need to mention. Then we can start with the next slides. Yes. Please read this link carefully, because as again is a section in the optimized DP200, and this link that I include, there is nothing particular about Azure service, but it is the data engineer general concept. So they will ask this, and in the DP200, and they will ask it again in like other exams regarding to data engineer. So these are not yet in the Azure knowledge, but it's the specifically data engineer domain knowledge. So you can see like cluster, column star, cluster index, heap. All of these I need to be aware when you design a database, when you query, or when you optimize a database and optimize your application. And also like the other girl, I forgot what her name is. Remember Synapse SQL pool, right? Is also a topic that will be tested in the exam. Same in here, is a very general knowledge of data engineer. So please go over these two links and read on this, and let me know if you have a question on this. Column store, remember, is just based on the columnar data format. Once you have that concept already, it shouldn't be giving you any difficulties. Okay, so let's go over and talk about data skew, because data skew is also a big issue in the distributed, and how Azure and other cloud providers each have different tools to deal with this issue, and the solution is very similar. So in a distribution system, when you distribute a table, right, it should approximately have the same number of rows. But then so the issue of data skew arises when one or more distribution have have a bigger or smaller rows than the rest. Then it will be a problem for query, because some distribution will finish their portion of a query before others. So it creates a very disproportional workload, you see. So let's go to this link so that we can talk more about this. This link is very important. You see in here, it talk again about like what is a distributed table. We already mentioned in here. This is the distributed table. And again, these are not like uniquely concept to Azure, it's everywhere. So in this article, so firstly, it talk about like different method of how to distribute this table. So hash, round robin, but then I want you to see this one here. Hang on. Let me see again. Give me a minute. Okay, so let me go over from one to the other. So when you distributed the table, remember you need to ask how large the table is, how often is table is refreshed, and do you have the fact or dimension table. Remember, fact or dimension table, I already write for you the keyword in the relational database 101. So you can, this is a concept in relation database or non-relational database. So please remember to go over it. So this algorithm, I'll go over it once we reach to Azure part, but I want you mention about this. Choose distributed columns, and how is data skew, and how you use and how you choose the distributed column to have the balanced processing. So let's see the definition of data skew. So data skew means that data is not distributed evenly across the distribution. And because of that, because of data skew, so remember the picture where one data is more than the other, it creates a balanced workload because the query is only as fast as the slowest query. So, if all other servers is finished before the particular one, you still need to wait for that one to finish before you can move on with your query. So that is what data skew is. And data skew led to process skew, which means that some distribution take longer while other is running in queries. Okay, so in order to avoid that, you need to select a distribute column that have this area. And this is one of the area I mentioned. Remember, in the partitioning, you want to partition data that group by a date column. But in the distributed system, you don't want the data that group by date column, because the date, you can have some date that is like some purchase date, that like one day you can have many purchase, and one day you can have like very, very little purchase. So that create the data skew, and that is the main thing I want to highlight in here. So please remember to read this. Most of this makes sense. Beside this could be confusing. So that's why I want to highlight with you. Like distribute, you have too many unique values. So there shouldn't be anything duplicated. Does not have nulls or have a few nulls. So all of these are very common sense. Besides, this is confusing. So that's what I want to highlight. And if you want to read more of what to choose on the good column, you can read more here. So, but then I have go through a few exam tests, and I mostly see that they ask on the concept. I don't see that they're gonna ask on like specifically on querying. So that's why I don't want to go through a lot of this, but I just want to go through you to remember these three concepts at first base. So that is for data skill, and please remember the concept of this, because from what I see, from what I go through with the questions on DP200 so far, is it more on scenario based of like a company has this system and what you should choose to avoid certain issues. So that's why I'm more highlight on the concept right now. So if I see on the example questions on more on like query and stuff, then I'll highlight with you guys on that particular part. So again, some pitfall of distribution system, I believe Harris and Julie already were in my Spark training, so you guys already aware of this, but it's basically just about sharding pro and cons, and sharding key and how to avoid the bottleneck on this. So Brian, since you wasn't in the last session in this, please go over to my sharding article to read more on this. I'll fix on this. I don't know why I'm missing the partition one here, but I'll fix on this later. So let me delete this for now so that you guys don't get confused. Okay, sorry about that. Okay, so let's go to Spark. So since you guys already know Spark, I'll just go very brief on the Spark architecture. Then we will use the last few minutes to talk about, NoSQL for different type, and we will talk about the data masking. So the core of Spark, right, is a Spark API. So from Spark core API, you can learn, you can use other functions or other feature of Spark, like Spark SQL, Spark Streaming, MLlib, Graph X, and Spark R. Mostly for Spark, if the question test, there would be more on the Python. I don't think they will test you on R or Scala, but I don't think they will go over in syntax. So let's just remember the architecture for now. Oh, sorry, I have one thing that I want to ask you guys. So in here is the quiz. I hope everyone see it. Let me. Okay. So this quiz, I got it from Microsoft Learn, and I think it will very closely to the content that we had in last class. So could you guys guess the answer for this? Okay, so let's have 1 minute on this, and just guessing the answer. Anyone give me the answer on this, to so that I can ensure that you guys remember this concept at least. The question on DB200, it would be very close to the second one, where you given scenario and they will ask you what you should choose, what you should do in this. Okay, you guys. Oh, hi Stu. You just joined, right? Okay, Silly, that is for question 2, right? Okay, yes. Okay, first one, which type of transaction? Okay, hang on. I'm get all mixed up from all the just message. So let me go back to my slide here. So the first one, I see Brian, you say OLAP, which is the wrong answer. So it's actually OLTP. So OLTP systems support the large set of user and have quick response time. So this is great for small and relative simple queries, transactions and query. So remember OLTP. And second, is it the C is correct? Yes. So that's it, the quiz. Remember, please go over this. Again, it's a very, very important concept and I see it over and over again. So since I see Stu just joined, Stu, do you know about Spark yet? Because most of the folks here, Brian and Harris and Sully, already know Spark. So if you don't know yet or you have no clue about Spark, let me know. Then I'll go slower on this and we can repeat it again also in the few next session when we go to Azure. So let me just go over the Spark session first. And if you still don't understand, let me know that I'll go to it slower. So, okay, let's talk about this again. So Spark ecosystem. So Spark offer many services. And remember what I said is that underlying of Spark, there's still a HDFS, which is Hadoop file system. That is where Spark used to store and to process data. And on top of that, they have Python, SQL, Scala, Java that you need to use in order to interact with Spark SQL, for example. So what is Spark? So it's fast, expressive cluster of compute system and it's compatible with Hadoop. So in some system design, you can install Hadoop and Spark at the same time. So you can have like Hadoop side with like Hadoop stack of technologies to run like you Hive Impala queries, and you can have Spark on the other side to run like workload like machine learning, big data processing, things like that. So it's compatible with Hadoop and work with any Hadoop supported storage system. And we talked about it already. S3 is AWS service, so please disregard this. I haven't edited the slide. And in here we have the concept of in-memory computing. Yes, hello, hi Stu. Please let me know if you would like me to go slower on the Spark session, because most of the folk here already have knowledge of what is Spark is. So remember about Spark, in-memory computing, rich API, interactive shell in Scala, and also for you can set up notebook, for example, Zeppelin and Jupyter to run Spark as well. So it's not limited to Scala. So when it comes to big data, Spark is kind of default tool to use. Before it was Hadoop, but then Hadoop is tied to Java, which is not optimized so much for like machine learning and data science workload. So that's why Spark become more and more popular now. And that's why it's also I put here that it's easier than map Hadoop and map reduce, because Spark has a very rich API and it doesn't tie to only Java. You can see that it supports many languages. And in Spark 3, there's the gap between Python and Scala is getting smaller. And that also one of the reasons why it's great to use Spark on cloud, because there's such an easy time to upgrade to a next version. So this is the architecture of Spark, but then it's very similar to all of the distributed systems. So a driver and an executor. So if you want, we can go back to this here. Remember, driver and executor. So I actually get this system from this picture from Spark. but then it's very similar throughout all of the distributed system. This is the common model. So let's go back here. Spark API. I don't believe they will test on this, but I'll just quickly talk to you that underlying of all other Spark API, they're always RDD. So this is the evolution of Spark API, and this is where we are now. But then underlying of all of this, there's still RDD who like processing. So the core of Spark API is RDD. Right now, most of the people who use Python who will use Spark data frame because this is the only option for Python user to interact with Spark through this. For dataset, it's a newer, but then it's only support in Java and Scala. And you can see about different data Spark Core API here. If you are a little bit confused, let me know, or you can watch my other training on Spark on this. Okay, and remember the Spark Core API, there's a very important core information is on transfer. Some API support transformation, and what transformation is select group by order by join, and action is count show write. And why there's a different on this, because Spark is the lazy evaluation, so it doesn't actually compute until you ask it for the action. So until you tell it to run, that it will run, otherwise it won't compute. So it's very different from Python, right? When you hit the run, when you just call like select something, it already select. But with Spark, it doesn't do that. When you ask for it to show the result, then that is the moment where it computes. Okay, so this is just more on like Spark API and how to like to have the persistent in-memory computing. So we won't go to this because it won't be test. And Spark SQL is just another tool to really use Spark easily, because not many people can use RDD nowadays. Most of prefer way to analyze data would be Spark SQL. And of course, if you want to do machine learning on Spark, then you have to use Spark MLlib. Okay, so let's talk about Spark and Hadoop ecosystem. I want to talk a little bit about on the Cloudera and Hortonworks and how things will had become now, because it's related to the HD Insight, which is also a cloud distribution system. And in the past, some students, some of my classmates have asked me on this. What is the difference between Databricks and Azure HD Insight? And that's why it inspired me to talk about the Spark and Hadoop ecosystem. So we know Spark and Spark technologies. So the company that because we have open source, right? So and also we have companies that deliver solution to enterprise and also deliver open source solutions on that technologies. So when you talk about Hadoop, you always remember about Cloudera and Hortonworks and their ecosystem on this. And when you talk about Spark, you always remember about Databricks, and Databricks is specialized for cloud data, while Cloudera and Hortonworks is specialized on the on-premise. And one of the good news or bad news depends on you is that in 2019, Cloudera and Hortonworks merged to one another. So nowadays, we just prefer to Cloudera. We don't talk about Hortonworks anymore. So back to my point, Cloudera and Hortonworks used to be the main provider for open source Hadoop. So with Apache ecosystem, most of them all of them are open source. So there's a huge ecosystem of different tools to do data engineer to control, to manage your system. So I just want to go over it. Sorry, we are a little bit over time, but bear with me for another 10 minutes. I promise there won't be more than 10 minutes. Apache. This is important because it's very important in the real life when you work with data engineer. So I want to highlight this. In Azure, of course, you will have a different Azure stack, so it is not that important. But in real life, when you start working, that is very important that you're aware of this. So Hadoop has a lot of ecosystem that help you to control and manage and optimize your whole data to make sure that like if you have a lot of data processing, you have a way to visualize it and to detect errors. So there's a vast ecosystem that go with Hadoop. And with Databricks, because it built on Spark, so it doesn't have this kind of richness of data, of richness of ecosystem. And of course it provides all the tools in place of that. But for people, for example, who come from the Hadoop on-prem system and they prefer to have the same environment, the solution is Azure HD Insight, because is it the cloud distribution that have both Hadoop and Spark together. So it make it easy, fast, and cost-effective way to process amount of data without leaving the environment that you already comfortable with. And it is something that really a strength of Azure, because remember, Azure is one of the chief cloud provider that very enterprise friendly, that offer the most pronounced hybrid solution that integrate with other stack in the existing legacy system of an enterprise, or like tools for like Excel, Power BI, a lot of things like that. So this is just another add-on the value that Azure has provided to the enterprise. So you can see here Azure HD Insight, so they bring both Hadoop and Spark under the umbrella. So it enable enterprise to manage both with the same tools that they already use on-prem. Because remember, Hadoop it has been exist for very long, and there's a lot of company still have a legacy system with it. And talking about Ambari Apache Ranger, things that companies already has and already use. And this is the way that Azure keep enterprise, because they provide extensive services that easily to integrate with the legacy system, sorry. So it support both Jupyter and Zeppelin versus Apache Spark, which is mostly support Jupyter. So I just want to briefly talk about NoSQL database. We will talk more about this when we go to Azure section. So remember when I talk about relational database, right? The contrast of relational database in non-relational database in NoSQL. So there's 4 types of non-relational database that we need to aware of. And there are also different, hang on, I need to switch to my, other computer to the same slide. So, sorry, yes, we are in the same slide. So there's 4 type of NoSQL database. So you have document, you have document where like just an extensive. So remember when I talk about key value, right? Is it the hash? This is very similar to hash table concept, where you have like a pair of key and value used together. So to extend to that is a document database, where you also take the key value concept to link the document together in a group of collections. And a columnar, we already talked about it several times during our course of columnar database and data set. And a graph database is very interesting, is where you connect node and edge together. So you can see, for example, one of the example of graph database is the relationship of people in a social network. So for the data in an organization, there will be multiple type of NoSQL. So there's no organization that just rely on one type. So no, so don't think about that. We can get rid of relational database, but think about that relational and non-relational database is living with one another to create a big data picture. So for that, we talk about data security. So remember, once you move on cloud, there are a lot of questions about data security. And remember that your data is not protected by one layer, but it's multiple layers that will protect your data together. So we will talk about each of these in the Azure section, because actually each of these, like network security, access management, threat protection in Azure is very unique in Azure and very different from other environment. So this one we will talk in Azure, a separate section in Azure, but I want to talk about the last layer, information protection. So with information protection, let's talk about the concept of data masking. So we talk about data hashing, right? Where we hide the data. So data hashing is a process where you use algorithm and different hashing methods to hide the data. And what the difference between data hashing and data masking is that hashing is not reversible, while masking is reversible. And there's two types of masking, which is dynamic and static masking. Static masking. So static masking is permanently replace sensitive data address, while dynamic masking is very popular and very critical on cloud. So there will be a proxy in the middle of the query of the loading between your data server and the analytical side. And that masking is ensure that the original data in the database is still intact and there's no change in that, while in the other side, the result that they receive is the data that's masked already. So to conclude the lesson, let me just bring you to the picture of the data masking. So that you can imagine of the data masking process. Oh, what happened? Yes. So you can see here, this is the process of data masking. Is where like you have a server in the middle where you do the masking of the data. And I talk about server, but it could be just a proxy in the middle where you can really process and mask the data on fly, so that once it reach to other people, they cannot see sensitive information. And here is another example where you have the report database and you have the data proxies. So the data here is not changed at all, but then through this proxy, all of the sensitive data is masked. And once it reaches the analyst will never know about your social security number, your date of birth, your name, anything like that. So these are the two concepts of information protection. Okay, so for today, that is it. And next week we will start to talk about Azure ecosystem. So far, do you guys have any questions? Oh, we have more people to join. Great to see you guys. Are you guys follow all right? Awesome. So, so since everyone was joining at the same as the different time, so let me just quickly go through what we have today, what we were going today, because next week we won't go over this content anymore, and we will move we will move to Azure, because these are the fundamental data engineer concepts, and we're done with it. There's no more review on this. So again, I want to stress on the you guys need to remember about OLTP and OLAP and columnar. Let me just actually go to the slide. OLAP and OLTP, and what workload is used for OLTP and OLAP, because it's very, very important. I cannot stress how important it is. It's more important than understand about like what is the difference between data lake and the data warehouse, because in the normal how do I say this, in the normal daily life, you really don't care about the difference. That is there, what is supposed to use for. But then OLTP and OLAP, if you don't understand, it will actually affect your work life in the organization. So really remember it by heart. Again, row and columnar oriented. It's not only for the exam. If you want to be in profession where you interact a lot with database, you need to remember this by heart. And if you want to build your career in big data engineer, or like anything that related to big data, you need to learn about distributed system. So vertical scaling, horizontal scaling. CAP theorem, very, very important, is the fundamental of a lot of other theorem that modern distributed system database is used for. Again, network partition is different from data partition you have learned by now. And consistency models, PACELC theorem, which is one of the concepts that I mentioned today. And I think that I have given enough information on explaining these letters, and I have also write a footnote on down here, and also the original paper if you are interested in learning more about that. So, and I understand like this theorem, it seems like it doesn't make sense when you first start at this, but once you see the Azure white paper, which is the main source that we will use for this class, you will start to make sense why I highlight about if partition exists, what will the system go for? Is the where is the default design is. And also remember another important on this is where is it? Yes, Hadoop, HDFS, HBase. What is the difference on this? Because this file system is regularly used in the distributed data store. So please remember on this. Or the concept on distributed data. This is to help us to have the similar vocabulary, jargon that used regularly in this industry. So please study on this slide and also on the links here, because these are the important jargons when we start talking about optimizing data. And as I showed you in the earlier session, this is actually one of the session in the DP 200. This is what I copy out of Microsoft Learn on this section. Okay, so data skew, also a very common issue, and also a common vocabulary knowledge that we need to learn. And data sharding, some pitfall, you can read the footnote here. We will go over it again once we reach to the Azure Cosmos DB. And Spark, for Spark in here, you just need to remember about Spark and Hadoop ecosystem. We will talk more about Azure Databricks and also Azure HD Insight in the later session. Yes, and this is 4 different type of database. And data masking, which is crucial. There will be one section that they quiz on how to protect your data on Azure and different security methods. So go over these two slides. All right, so that's it for today. Thank you so much, guys. And if you have any suggestion or questions, please let me know. I'll hang out in here for a few minutes, and after that, then I'll off. So also have a good day.